Hi, in Microsoft Fabric we can use Power Query to ingest data into our Lakehouse and of course use notebooks to perform calculations, transformations and visualizations. So we can follow an unconventional approach of using Power BI to get the data into the Lakehouse and use the notebooks to visualize the data. So I'm going to demonstrate a simple example of calculating some simple process metrics named cycle time and using the approach that I described. So here we are in my Power BI / Fabric workspace and in my OneDrive. So I have this process log example generated by ChatGPT. It's a mock-up process log, and as you can see, for each process step we have the process ID here, the timestamp of when the step was performed, what kind of step it was, the user, etc. But I did not prompt effectively ChatGPT, so in some cases we have multiple start steps. So in process 1006 we have a start step in line 30 and a start step in line 42. So we have to take that into account during our work. So the first step in Microsoft Fabric would be to create a data lakehouse. I'm going to the data engineering perspective and create a new lakehouse. I give it a name, Map Lakehouse Map, and I'm creating it. As you can see, there are two folders, tables and files. So delta tables are created in the tables folder, and we can also upload all sorts of files in the files folder. So I can go back to the Power BI demos workspace. Marketing demo is something completely different. And here we have the Lakehouse, an SQL endpoint for the Lakehouse, and the default dataset to create paginated reports mainly. And we can create here a data flow generation tool, which is a Power Query experience for ingesting data directly into the Lakehouse. So I'm going to create a new Power Query data flow. So an alternative way to create a Power Query data flow would be to go to the home page of your Lakehouse and use this new data flow Gen2. And this will ensure that the data flow will use the Lakehouse automatically as the target for the end result. So this is the Power Query user interface, and we can import our data from OneDrive. And this might not be the case, so it might not understand that our data destination should be the data lakehouse, and it will have a plus icon here where we can create a new data destination. So this is the Power Query user interface, as I said, and I can do things I usually do in Power Query, like removing the columns that I don't want. And also rename the data flow to ingest into Data Lakehouse using Power Query. Anyway, publish. So after the notebook is created, we can read the table into a data frame. So I'm gonna read the table. This for the process. Log example. So I'm also going to display the data frame to ensure everything works fine. And as I said, there are multiple entries for various activities in some processes. So I'm going to group by the process ID and the activity and select the minimum timestamp as the correct time the step was actually performed. So let's do group by process ID and activity. And aggregate the timestamp column by minimum. Let's see what's going on. And I also want to rename the min timestamp column to something more appropriate. So min timestamp to step time. See, so okay, and instead of showing the result, I want to write it to a delta table. So it's write format delta. Perhaps we can do mode override, but we don't have table already. If we did, and save into the tables folder. So it is table, the delta table. And we can refresh the tables folder to see our table. So now we can switch to SQL Magic and select start from our table to see what happens. We can also order by process ID and step time. And as you can see, we have a start for the first process, step 1, 2, 3, 4, end, then start of the second process. And as you remember, we had multiple start steps in process 1006. Now we have unique. And what we want to calculate at the end of the day is the difference between the start and end time for each process. So we can do that in SQL as well. So let's go here and try to demonstrate. Okay, so I can also create a CTE, a common table expression here, and select only the start steps, join that with the end steps, and then perform the calculation, the subtraction of the two times. So let's do the first select. So I'm gonna select process ID and step time from test 1, where activity equals start. Let's press select. Yes. And I'm gonna do like CTE as select. Go for just an intermediate step, CTE1, so CTE2, that's the start one, so it's process ID equals CTE2 process ID. So we have the start steps and the end steps here. So at the end of the day, we want the process ID, and we can take it from either CTE1 or 2. And the difference is between the end step time, CTE2 step time, and the start step time, CTE1 step time. And if we cast them as doubles, it will convert them to seconds, so we'll have the cycle time in seconds. So I'm going to take process ID and cast the end step time as double, and subtract the start time, well, casting it first double, and I can also do a chart and understand immediately that the process which took the longest to complete is case 1012. It took 7,623 seconds. The case that took the less time to complete is 1009, and I can of course divide by 3,000 pips and 600 to have cycle time in hours. And I can also save an image and have this visualization. So this is it. We ingested the data using Gen2 DataFlows, Power Query DataFlow into the Data Lakehouse, and processed the data to duplicate the records, and visualized the average duration, the duration of each case in the notebook. Thank you.